Okay, we're going to talk a little bit about our last category for names and formulas. These are the hydrocarbons. And as you can kind of guess by the name, hydrocarbons, made up of hydrogen, also made up of carbon. Okay, and there's 10 of them that you need to know how to name. And we'll kind of put a pattern to it here in a minute. But the first thing to mention to you here is anytime we link carbons together in single bonds, kind of a chain of carbons, if they're all single bonds, we call those alkanes. Okay? And if you take organic chemistry, if you go beyond this class, potentially even, well, in AP chemistry, you would cover this too. But definitely if you go beyond AP chemistry and get into organic chemistry, there's a lot with carbon, hydrogen compounds, a lot of structures to name and write formulas for. So this is kind of the foundational part that you have to know and understand as you move further in chemistry or biochemistry and you have to name stuff. Okay, so the first one here, this CH4, is when you have carbon bonded to 4 hydrogens. And I want to kind of show you with the model kit today what these look like. This is carbon bonded to hydrogen in 4 different directions. Okay, 4 equal and opposite directions. Unit 10 later in the year, we will actually get into drawing these structures. But this is called methane. This is called methane. That is just something you're going to have to know when you have 1 carbon and 4 hydrogens connected together. This is called methane. Okay. Now, if I were to pull off one of my hydrogens and connect it to another 3 hydrogens connected to a carbon, so I put a string of 2 carbons together. Notice I have 3 hydrogens on this side, 3 hydrogens on that side. 2 carbons, 6 hydrogens. That's why the formula is C2H6, so it's a chain of 2 carbons. This is called ethane. And maybe you've heard of, for instance, ethanol before. Ethanol is based off of the fact that ethane has 2 carbons, right? So you put those together, that is called ethane. The next one, if I were to take off one of the hydrogens, okay, and I were to connect it to another, if I were to connect it to another carbon, okay, so I have 3 carbons. Let me grab one more hydrogen here. 3 carbons in a row. 1, 2, 3. And there's 3 hydrogens on this end, 3 hydrogens on that end, and this one in the middle actually only has 2 because carbon can bond in 4 directions. So this is CH3, a CH2, and then a CH3. If you were to add all that up, that's 3 carbons, 8 hydrogens. That together, anytime you have 3 carbons linked together like this, we call that propane. Notice the endings. We keep saying ane. It has to do with the fact that there's our straight chain links of carbons called the alkane series. Propane, you've probably heard of propane before. When you go to get the refill for your gas grill, that's propane that you go get refilled, the propane tanks, right? Okay, so if I were to pull off on one end, if I were to pull off and connect to another carbon, and therefore I have a link of 4 carbons together. Notice 1, 2, 3, 4, straight chain. Well, this is as straight as it goes. Has to do with the geometry of it. We'll get to that later in the year. But 4 carbons. This one has 3 hydrogens on this end. This one has 3 hydrogens on that end. This one has 2. This one has 2. This 4 carbons, we call this butane. So think of a butane lighter. Okay, those molecules in a butane lighter, they look like this. 4 carbons and a total of 10 hydrogens, right? And then if we were to pull off and connect to another carbon, so therefore that we have a chain of 5, you kind of get the point of this. This is called pentane because it has 5 carbons and then a total of 12 hydrogens. So this is called pentane. 5 carbons. That's a pretty easy prefix. If I were to pull off and add another one, so I have 6 hydrogens. six carbons across the middle and a bunch of hydrogens around it. This is called hexane because it has 6 carbons, so it's hexane, and so on. I'll show you decane here in a minute, the last one, but this is called heptane when we link 7 carbons together and we put all the hydrogens on there. This one you should be familiar with. This is called octane because it has 8 carbons connected to it. So when you go to the gas station, if you something you maybe haven't noticed, next time you go check, there's an 87, 89, 91 octane rating. It really has to do with what percent of what's coming out and going into your car is actually the octane molecule itself. Next one, the 9 prefix is nana, so it's nonane. Nonane. And then the last one, deca, is our prefix, so we use decane. Okay? And that is a series of 10 carbons. Let me see if I can hook this together for you real quickly and show you all 10 of them connected. It's kind of a longer molecule. Here we go. So 10 carbons linked together with as many hydrogens as possible around it. 10 carbons. And in this case, it has 22 hydrogens attached. Okay. Now, if you haven't noticed, there's a pattern to this, and this should help this in terms of memorization for formula purposes. Notice whatever number of carbons, you double it and then add 2 more, and that's going to be the number of hydrogens. So if I have, for instance, 7 carbons, double that, that's 14, add 2 more, you get 16. So the pattern here is whatever C is, we're going to say is X. You're going to get the number of H's, you do 2X plus 2. That is your formula for these alkanes. Okay. Now, how are you going to memorize this? That's a good question. A lot of these, I think you know the prefixes. For instance, penta, you know, for 5, hexa 6, hepta is 7, octa for 8, nana 9, and then decane, deca for 10. I think the first 4 are the hardest: methane, ethane, propane, butane. So do the best you can. I've heard the acronym before: me eat peanut butter. Think of Cookie Monster voice, somebody saying me eat peanut butter. That's one way to remember these first 4: methane, ethane, propane, butane. Somehow you need to know these. These are your hydrocarbons. Going the other direction, if you have a name, all you got to do is come up with how many carbons and then double plus 2 on the number of hydrogens.